got done doing compound inequalities, which challenged us a little bit. Now we're going to throw the absolute values at you again, just like we did with equations. And they got challenging because you actually have to think a little bit. Okay, you can't just go and attack it. So before I teach the little tricks to this, let's think about what this means. So I'm saying the absolute value of some number is less than 3. And I want to figure out what numbers I can put in for x to make that inequality true. Well, let's think about the different positive numbers that I can put in. If I took let's just start at 3. The absolute value of 3, is that less than 3? Well, absolute value of 3 is 3. Is that less than 3? No, that does not work. Okay, so I can't use 3. Could I go bigger than 3? No, because then the absolute value of 4 isn't less than 3. So I'm going to have to go a little bit smaller. So like the absolute value of 2 is less than 3, right? Because the absolute value of 2 is 2. 2 is less than 3. So I could put in 2 for x. I could also put in a 1 for x, right? The absolute value of 1 is less than 3. I could also do a 0, right? The absolute value of 0 is less than 3. What about some negatives? Can I do some negatives? Well, let's think. Let's just go to -1 right away. Absolute value of -1, is that less than 3? Well, the absolute value of -1 is a positive 1, and that's less than 3, so I'm good. Same thing with -2. Absolute value of -2 is a positive 2, and that's less than 3, so that works. Well, if I go to the absolute value of -3, that's 3, isn't it? And 3 is not less than 3, so this does not work. And so if I jump to the absolute value of -4, that shouldn't work either, right? Because that is not less than 3. The absolute value of -4 is a positive 4, so that doesn't work. So just looking at my integers, it kind of goes, 2, 1, 0, -1, -2, and the 3 and the -3 don't work. So if I were to graph this, let me go ahead and put 0 in the middle. 1, 2, 3, 4. 1, 2, 3, 4 in the negatives. Get rid of this guy here. That's a 1, 2, 3, 4. If I graph this, kind of like what we did with the compound and all those other graphs, really, -3 doesn't work. Either is 3. But if I put in like 2.9, that would work. So that's why I need to put the circles at 3 and -3. And I'm looking at everything in between, all right? The intersection in here. Nothing works outside of it, right? We looked at if I tried to do absolute value of 4, that would work. If I tried to do the absolute value of -4, that didn't work. So x could be anywhere from like -2.9-ish to 2.9 because we don't include -3 and 3. That's why I didn't put a closed circle. I put an open circle. Well, how could I have done this mathematically instead of just trying to think through it? Well, let me show you. So here was our original equation. Anytime I have a less than sign, I can just drop my absolute value bars, and I can say x is less than 3. That'll be one of my inequalities. The other inequality I set up is I drop the absolute value bars, I flip the sign, and I make the other term negative. Or I make it opposite, so I make it negative in this case. So let's look at that rule again. So basically, the first one, I just drop the absolute values and I leave it, right? Keep it as less than. The other one, drop the absolute values and I switch both things. Change the sign, change 3 to a -3. Make it the opposite value. Well, and then I can combine these in the end. I put my smallest number first, -3, have it pointing to -3, then put my x. And then I give my other inequality. Well, x is also less than 3. So there you go. So what do you notice? If I have a less than symbol for an absolute value, that makes an intersection. That makes an intersection. Okay, and I made it nice and neat. That's a lot better than having to think through it. So let's try that for number 1 over here. So what did I say? I said the first one, if it's a less than or equal to, all I have to do is just drop the absolute value bars and leave it. And we said it's an intersection, so really I have the word and. And then my other one will be the same thing, drop the absolute values, we flip the sign, and we make 12 a -12. Make it the opposite term. And then it's just our algebra. So I add 3, we got n is less than or equal to 15. Done with that one. Over here, add 3, I got n is greater than or equal to -9. And let's go ahead and graph. I'll count by 3's in this case. 9, 6, 3, 0, 3, 6, 9, 12, 15. So at -9, 0, 6, 12, 15. And it looks like I have, well, I want to combine this, right? Because I have an and. So I'm going to say -9 first, right? Smallest one first. Have the point at the -9. And then my n. And then n is also less than or equal to 15. So it looks like I have a closed circle at -9, so I'm including -9. I have a closed circle at 15, so I'm including 15. And it's an intersection. So basically I can put any number from -9 to 15 in for my variable over here, in for n, and my inequality would make sense. It would be true. Right? And I can always test that. I could grab a number, I could grab like 9 here, 9 works. So if I grab 9 and plugged it in, for n, 9 minus 3, and the absolute value of that, see if that's less than 12. Well, the absolute value of 6 is 6. Is that less than or equal to 12? Yep, it checks out. Good. Okay, how about this other one? I should have, my sensor should be clicking here. Because look, remember, can I ever take the absolute value of a number and get a negative answer? No. Can never take an absolute value and get a negative. That can never happen. Well, let's think about what my inequality sign here says. Can I take the absolute value of some number and get a number that's less than a negative? Well, any number that's less than -8 has to be a negative. So if I took the absolute value, it would have to be a negative that's less than -8. Well, can I ever take the absolute value of something and get a negative answer? No, no matter what. If I take the absolute value of -10, I get 10. If I take the absolute value of 10, I get 10. So I can never take the absolute value of something and get a negative. So this could never happen. I can never take the absolute value of a number and get something less than -8. So there is no solution for x. Or like some of you like to say, the null set. Right? There's no solution I can plug in for x to make that inequality true. Okay, so just be cautious when the negative is on the other side by itself from the absolute values. Well, what happens if it's greater than or equal to? Let's think about this. Are the same type of things going to happen? Am I going to plug in like the square root of 2 and have it be greater than 3? Well, 2 is not greater than 3. So it looks like I'm not going to be using numbers less than 3 this time. Well, 3 doesn't work because 3 is not greater than 3. So let's jump to 4. The absolute value of 4. Is that greater than 3? Yes. So it looks like the more I go up, it works just fine, right? Good. Well, what happens if I do negatives? So if I took the absolute value of -4, is that greater than 3? Yep, because the absolute value of 4 is -4 is 4, and that's greater than 3. So if I keep getting smaller, plugging in smaller numbers for x, absolute value of -5 is 5, that's greater than 3, so that works. So if I think about this on the number line, put 0 here, got by 2, 4, 6, 2, 4, 6. So if I think about this, 3 and -3 don't work. So there's like open circles there. And, well, numbers bigger than 3 are working, right? If I plug in a number bigger than 3. And also if I plug in numbers that are smaller than -3, right? Because the absolute value gives me the positive. And it seems to work. So what's my trick going to be here, you think? Well, if I look at it, it looks like with the 1, I can just leave, right? Drop my absolute values, go less than 3. It works. Well, I think the same thing works, doesn't it? I drop the absolute values, I flip the sign, and I make it negative. And the same thing works, except in this case, it's not an intersection anymore. It's an or. So anytime there's a greater than with the absolute values, we got an or. But the same type of rule applies. Drop the absolute values, leave it, drop the absolute values, and switch both, the sign and the term. So let's try it once. So now I have a greater than. So now I'm thinking or. This is a union. Okay, so I drop the absolute values. 2k plus 1 is greater than 7. And now it's an or. And do the other one. Drop the absolute values, flip the sign, change the term to its opposite. So make it negative. And now it's our algebra. So subtract 1 from both sides. 2k is greater than 6, divide by 2. And we got k is greater than 3. And now it's or. So subtract the 1, 2k is less than negative 8. Divide by 2, k is less than negative 4. And I can graph that. Negative 4, 3, 2, 1, 0, 1, 2, 3. Looks like I have a open circle at 3. I'm going numbers greater than that. And a open circle at negative 4 and numbers less than negative 4. So there we go. So greater than with the absolute value is going to give me an or as I go through. It's kind of the same type of rule. Well, is this going to be the same situation? You think this will be no solution for number 2? Let's think about it. Can I take the absolute value of a number and have it be greater than a negative 5? Have it be greater than a negative 5. Well, let's think about that. If I take the absolute value of any number, it doesn't matter what I put in for r, just think about any number. If I take the absolute value of negative 12, that's 12. If I take the absolute value of 12, that's also 12, isn't it? So anytime I take an absolute value, that's positive. Well, if I take an absolute value of a number, I know it's going to be positive. And isn't every positive number greater than negative 5? Every positive number is greater than negative 5. It's greater than any negative, isn't it? So I can plug in any number for r, and it works. Right? I could plug in anything for r, and it would make sense. Right? If I plugged in a negative 20, negative 20 minus 6, absolute value, that would be negative 26. The absolute value of negative 26 is 26. So 26 would work, right? Because that's greater than negative 5. So everything works. So what's my solution for r? Well, everything is. So we say all real numbers, because everything works. So you actually have to think about it whenever there's the negative on the other side of the absolute value bars. Okay? So a little bit different. And with sorted problems, we're not going to actually write our inequalities for this. Just go ahead and solve, okay? Because we're not going to spend the time to come up with the formula for the inequalities. You'll do that later in your math career. So right now it says the average annual rainfall in California for the last 100 years is 23 inches. However, the annual rainfall can differ by 10 inches from that average. What is the range of the annual rainfall from California? Well, 23 is the average. It could either go up 10 or down 10. So the range is what? From 13 to 33 inches. Okay, just go ahead and do the math. Add 10 and subtract 10. Because we're not going to spend the time talking about, it's really the absolute value of a number subtracted by whatever your average is equals what your kind of your absolute value, what you're going up and down by. That's how you'd set it up. And in this case, we're doing the range, so I'm doing an intersection, so I put less than. So we're not going to spend the time doing that. Just go ahead and do the math, and then you're good to go. So there you go, just about done with chapter 5. So a little bit on the absolute values with our inequalities.